Okay, first we're going to look at the review problems, and I'm going to write the problems down on here, but you have your review as well. So the first problem we have is solving using Gauss-Jordan elimination by hand. So we have 2x plus y equals -1, and x plus 3y equals 2. So I have these two equations, how I need to set up a matrix. So my matrix is going to be 2, 1, -1, and 1, 3, 2. Now what I want to do is I want to set up a column of matrices and a column of row operations to keep my work organized. So I have my first matrix. What I want to do is I want to have a 1 in that first entry. So I need to switch row 1 and row 2 so that I have 1, 3, 2, and 2, 1, -1. My next goal is to make this 2 right here a 0. In order to do that, I'm going to have to multiply row 1 by a -2 and then add that to my row 2. So -2 times row 2, -2 times row 1 is going to be -2, -6, -4. And my row 2 is 2, 1, -1. So I just add those together. So I get 0, -5, -5. My new matrix is then 1, 3, 2, and 0, -5, -5. My next goal is to make this 5, or this -5, a 1. So my next row operation will be to multiply row 2 by a -1/5. That will make this -5 a +1, and that other -5 a +1. So that this now becomes my new row 2. So I have 1, 3, 2. And 0, 1, 1. Now what I have right now is I have what's called row echelon form, where I have my diagonal of 1s and 0s underneath. Now what I want to do is I want to make this other 3 a 0. That's what Gauss-Jordan elimination does. So I'm now going to work backwards, and I'm going to use my row 2 to eliminate that 3. So how can I use this 1 to eliminate that 3? I'm going to be multiplying my row 2 by -3, and then adding that to row 1. So -3 times row 2 is going to be 0, -3, -3. Row 1 is 1, 3, and 2. Okay, so I have 1, 0, and -1 when I add those together. This is going to replace row 1. So now I have 1, 0, -1, and 0, 1, 1. Now in my augmented matrix, what this tells me is that I have 1x plus 0y equals -1, and I have 0x plus 1y equals 1. Or in other words, I have x equals -1 and y equals 1. So my solution then is just -1, 1. So I've used Gauss-Jordan elimination to get this form right here, which is reduced row form, to give me my solution. Okay, now let's All right, so we're going to look at our 3 by 3 system with 2x minus y plus 3z equals 2, x plus 2y minus z equals 6, negative x minus y plus z equals negative 5. The first thing I need to do is set up my augmented matrix. So it's 2, negative 1, 3, and 2. 1, 2, negative 1, 6. Negative 1, negative 1, 1, and negative 5. Now I need to set up my columns. So I'm going to have my first matrix is my pink one up here. I always want my first row, first column entry to be a 1. Notice I have a 1 in that second row. So I'm going to switch my row 1 and row 2 to make sure that I have my first entry to be a 1. So I have 1, 2, negative 1, 6. 2, negative 1, 3, and 2, and negative 1, 1, and negative 5. Next, what I want to do is I want to start eliminating everything underneath that 1. So I want to start working on eliminating this 2. I want to make that a 0. In order to do that, I'm going to multiply my row 1 times a negative 2, and then add that to row 2. A negative 2 times row 1 will be negative 2, negative 4, 2, and negative 12. Then I'm going to add that to row 2. So that gives me 0, negative 5, 5, and negative 10. This is going to replace row 2 in my matrix. So when I write my new matrix, I now have a 0 instead of that 2. Negative 1, negative 1, 1, and negative 5 there. Next, what I want to do is I want to make sure that I eliminate that negative 1 in my third row. In order to do that, I'm going to add row 1 to row 3. So I want to use row 1 to help eliminate that. Notice I have that negative 1 here, and if I add that to my 1, those will eliminate. So I'm just adding my row 1 and my row 3 together. So I have 0, 1, 0, 1. That's going to replace row 3 in my matrix. So 1, 2, negative 1, 6, 0, negative 5, 5, and negative 10, 0, 1, 0, 1. Next, I need to look at my second column, and I need a 1 to be right here. I have a couple of different options. I can notice that I have a 1 here, and I could just switch. I could also multiply my second row by a negative 1/5, and that's what I'm going to do here. So my negative 1/5 times row 2 gives me 0, 1, negative 1, and 2. That's going to replace row 2. So I have 1, 2, negative 1, 6, 0, 1, negative 1, and 2, and 0, 1, 0, 1. Now, just like I did earlier, I eliminated and got zeros underneath that 1. I'm going to do the same thing here with this entry, with that 1. I'm going to now use my second row, though, to eliminate that. So my matrix operation, or my row operation, will be a negative times row 2, and add that to row 3. So negative times row 2 is 0, negative 1, 1, and negative 2. Add that to 0, 1, 0, 1. So I get 0, 0, 1, and negative 1. That's going to replace my third row in my matrix, so that I now have, sorry, let me move back up a little bit. 1, 2, negative 1, 6, 0, 1, negative 1, 2, and 0, 0, 1, negative 1. Now with that last step, you might have noticed that I ended up with my row echelon form here, where I have my column of ones, my diagonal of ones and zeros underneath. But in order to fully do Gauss-Jordan elimination, I need my other entries here, here, and here to also be zeros. So I need to do a few more row operations to get rid of those. So to get rid of this negative 1 right here, I'm going to use row 3 to do that. So row 3 plus row 2. Notice I don't need to multiply by anything, I can just add them. So row 3 is 0, 0, 1, negative 1, and 0, 1, negative 1, 2. So I have 0, 1, 0, and 1. So now this is going to replace row 2. So I have 1, 2, negative 1, 6, 0, 1, 0, 1, 0, 0, 1, negative 1. Now I need to work on this one. So notice I can just add the row 1 and row 3 together. So row 1 plus row 3. So 1, 2, negative 1, 6, plus 0, 0, 1, negative 1. Gives me 1, 2, 0, 5. That's going to replace my row 1. So I was trying to eliminate that negative 1. So 1, 2, 0, 5, 0, 1, 0, 1, and 0, 0, 1, negative 1. My last step is to eliminate this 2. I have to use another entry in the column to do that. So I notice I have this 1 here. So my row operation is going to be negative 2 times row 2, and then add that to row 1. Negative 2 times row 2 will be 0, negative 2, 0, negative 2. Add that to row 1, 1, 2, 0, 5. So I have 1, 0, 0, 3. That's going to replace row 1. So I have 1, 0, 0, 3, 0, 1, 0, 1, 0, 0, 1, negative 1. Notice this is my reduced row echelon form, where I have my diagonal of 1s and 0s in every other entry in that square matrix. Now, my solutions are that last column. I can write those as a triplet. For example, I can write 3, 1, negative 1. That would be my solution. 3 would be x, 1 would be y, and z would be negative 1. Okay? I'm going to be looking at writing a matrix from a system. This is going to be really simple. All you do is use the coefficient. So if I have 4x minus 2y plus 3z equals 4, 3x plus 5y plus z equals negative 7, and 5x minus y plus 4z equals 6. Writing an augmented matrix from these are really simple. Just make sure to include all of your coefficients. So 4, -2, 3, and 4, 3, 5, 1, and -7, 5, -1, 4, and 6. Now make sure if you had a system like this, let me scroll down here. What if I had a system like this, x plus y plus z equals 6, 2x minus y equals 3, and y plus 3z equals 0. What would I have to put in place for here and here? I can't leave entries blank, so make sure that you put zeros in those places. So I would put a 2, -1, 0, and 3. 0x, 1y, 3z, and a 0. So make sure you put zeros in those places that you have blanks in your system. Next, if I have a matrix, how can I write the system? How can I go backwards? So if I have 2, -2, -2, 1, 1, 4, and 3, 5, 8. That's exactly like putting an x, a y, and an equal sign in the matrix. So I would have 2x minus 2y equals -2. X plus y equals 4. 3x plus 5y equals 8. And there's my system. Again, if you're missing an entry, so for example, if I had a 0 there in my matrix, I would then not have that term in my system. So that equation would then just be x equals 4. All right, solve using the calculator. I don't have a way of showing my calculator on here, unfortunately. So what I'm going to do is I'm just going to be writing down what my calculator says. So I have the system, x plus 2y equals 11, -4x plus y equals -8, 5x plus y equals 19. So I need to set up my matrix. So I have 1, 2, and 11, -4, 1, -8, and 5, 1, and 19. So to put this in your calculator, you need to go to your matrix, so second matrix if you need it. Go over to Edit, put in your rows and columns, so this is a 3 by 3, and then put in your entries. Then go back to your home screen, go back into Matrix and choose Math. Make sure you choose the option for RREF for your reduced row echelon form with all ones and zeros. Then press Enter. Go back to your matrix and choose your matrix that you entered. Now, my last matrix for this system is 1, 0, 3, 0, 1, 4, 0, 0, 0. Since I have that last row of zeros, that's a true statement, so I know I have a solution. And since I only have 2 variables, my solution is 3, 4. Okay, what if I have a system of 3 variables? So if I have x minus 2y plus z equals 5, 2x plus y minus z equals 2, negative 2x plus 4y minus 2z equals 2. Okay, so I want to make my matrix first. So 1, negative 2, 1, and 5. 2, 1, negative 1, and 2. And negative 2, 4, negative 2, and 2. This is a 3 by 4, so when you go into matrix, make sure you change your dimensions so that you can plug in all of your entries. So 1, negative 2, 1, and 5, 2, 1, negative 1, 2, negative 2, 4, negative 2, and 2. Now what I get as my last matrix is 1, 0, negative 0.2, 0, 0, 1, negative 0.6, and 0, and 0, 0, 0, 1. Now, what does that last statement tell me? Or that last row? This last row tells me that I have 0 equals 1. That's a false statement. So whenever you end up with a row that ends up with a false statement, that means no solution. So you can't go any further. There's nothing else that you can do. There's just no solution to that system. And I believe you'll find the same thing on part C there. I'm going to go ahead and move on to okay. Matt took clothes to the cleaners 3 times last month. First, he brought 3 shirts, 1 pair of slacks, and paid $10.96. Then he brought 7 shirts, 2 pairs of slacks, and a sports coat, and paid $30.40. Finally, he brought 4 shirts and a sports coat and paid $14.45. How much was he charged for each shirt, each pair of slacks, and each sport coat? When you're given a word problem, you need to try and identify what you're searching for first. So here we're going to let X equal the cost of each shirt. We're going to let Y equal the cost of each pair of slacks, and Z equal the cost of each sports coat. Now I need to set up the system. So we have a total of 3 times. So first he brought 3 shirts, so that's 3x, and a pair of slacks, so plus y, and he paid $10.96, so 0z equals $10.96. Then we have 7 shirts, 2 pairs of slacks, and a sports coat for $30.40. Then we have 4 shirts and a sports coat for $14.45. So that's my system of equations. Now I need to set up a matrix. So I have 3, 1, 0, 1096, 7, 2, 1, 30.4, and 4, 0, 1, 1445. Now I can put this in my calculator. So I'm going to go to my matrix, edit. This is a 3 by 4. So 3, 1, 0, 1096, 7, 2, 1, 30.4, and 4, 0, 1, and $14.45. And what I get when I do my reduced row form in my calculator is I get 1 0 0 0 1 0 0 0 1, and then each shirt would be $1.99, each pair of slacks will be $4.99, and each sports coat is $6.49. So that tells me my solutions here. X is $1.99, Y is $4.99, and Z is $6.49. Okay, one I didn't get to do is one where we have a dependent system. So I want to really look at one like that, where we'll have dependent system. Dependent means we have an infinite amount of solutions. So whenever you have a matrix that you either do by hand or do in the calculator, and your final row echelon form looks like this. You may have some numbers here, but then you end up with zeros down here. That means that Z doesn't have a solution here. So we don't have a solution for the entire system. We actually have an infinite amount of solutions. We don't have a single solution, we have infinite solutions. So just as in we had our system where we had a false statement in that last row, if we end up with a system with a true statement like 0 equals 0 in that last row, that's going to be infinite solutions.